Good evening. Welcome back to AP Stats Notes Online. Continuing our conversation about regression analysis, least squares, regression lines, what we're going to talk about today. I mentioned before there are a lot of different regression lines out there, and you guys have explored at least one other type in pre-calculus in the form of a median line. That's one form of regression analysis. What we talk about in AP statistics is a least squares regression line, and here's why. First things first, and I'm going to jump over to the next page. I think it makes more sense to know what a residual is before we talk about a least squares regression line. So, all right, so we know that we're going to use our regression equation to make predictions. My question would be, are those predictions going to be exactly what the data says every time? If we were to draw, let's see, if we were to take this line, that line in our Honda CR-V example there is a regression line. And so if our regression line, if the prediction we use from the regression model is exactly the same as our actual data, then all these dots would fall on the line. And since they're not, that means that our predictions are going to be off. Some of the predictions are going to be off. Some might be exactly right. So when we're off, when the prediction is off, we get what's called a residual. So the definition of a residual is the difference between an actual response value and a predicted response value, found pretty easily. We're simply going to always, so that's important to understand. We will always calculate a residual by taking the actual minus the predicted. The reason why we always do it that way, and we want to make sure that we're going the same way with our residuals all the time, is that it makes it a lot easier to interpret those residuals. Okay? So since the predicted always comes second, then obviously since we're subtracting, sometimes we'll get a positive residual and sometimes we'll get a negative residual. If we get a positive residual, that means our prediction was less than the actual data. So that means our regression equation under-predicted, right? Since the predicted is under the actual data value. So this, we under-predict when our residual is positive. When our residual is negative, that means our prediction was higher or larger than what the actual data said. And so that means that our regression over-predicted. And so if our residual is negative, then our regression equation over-predicted. Okay? And so that's how we're going to interpret it. The regression equation, over-predicts or under-predicts, depending on the sign of our residual, the response, the y, by so many units. And the y and the so many units are in blue because that's where we're going to add our context, right? We always want to make sure we pull the context from a situation. So that's what a residual is. A residual is just an error. It's how far off we are when we make a prediction, okay? Sometimes those residuals are 0, and that would be a good thing. All right? That leads us to a least squares regression line, okay? So go back to the previous page. I think it makes more sense to move this question, and I'll do so some other time. But anyway, what is the least squares regression line? It's a type of regression line out of the many that are out there. Again, median line is a form of regression. But we talk about the least squares regression line. That's a line that minimizes the squared differences between the actual and predicted. In other words, residuals. It's a line that minimizes the squared residuals that we get from a regression model. Okay, y squared, well, it's kind of the same as we've talked about with standard deviation, right? If we're going to start adding residuals, and we will in the form of the standard deviation of residuals, which we'll get to later, then we don't want this canceling effect of positive and negative residuals. So we square them to make them all positive, and we get a more accurate view of our residuals. So of how well the line does at making predictions. So that's what a least squares regression line does. It minimizes those squared residuals. It tries to make those residuals, those squared residuals, as small as possible. Okay? So, for example, this guy right here, for the Honda CR-V and miles driven example, this is a least squares regression line, because if we were to find the residuals, so here's all of our prediction values on the line. Well, some of these actual price tags are higher and some of the price tags are lower based on certain miles driven. And so this is our actual data. If we were to drop a vertical line, that would represent the residual. This distance is the residual. This guy right in here is our residuals. And so when we draw a best fit line, in order to get a least squares regression line, we want to draw this line to where all of these residuals are as small as possible. Obviously, if I pulled this line down, it would make some residuals smaller, but some residuals larger. If I pulled this line up, same thing. So this line is positioned so that those residuals are as small as they can possibly be, and therefore the squared residuals would be as small as they can possibly be. Okay? That's what a least squares regression line does. It has all the same properties of any other regression line, where it has a slope and a y-intercept, and we interpret the slope and the y-intercept the same. None of that stuff changes. It's just why we position the line where we do. Okay? So now let's talk about how we want to calculate the least squares regression equation. We do not want to do this by hand very often. There is a way to do it. I'll show you that in a couple of minutes, but our calculator will do all of that heavy lifting for us. So there's an example here we can go through, and this least squares regression applet we'll take a look at in class tomorrow, or maybe Thursday. Tomorrow might be a good day, since we're going to meet for about 15 minutes. So we may take a look at that tomorrow, and then Thursday we'll have some time to do some homework as well. But anyway, what I need you to do is, and if you want to stop the video, that's fine too, but go ahead and for a year, and I can't remember what year this was, but for a particular year, ice cream sales and number of shark attacks in every month of that year were recorded. And this was in Florida. So someone wanted to find out if there was a relationship between ice cream sales and shark attacks. So there's the data. Go ahead and type the data into your calculator, and we're going to put this into two different lists, right? Doesn't matter which two lists you use. I'm going to use list 1 and list 2, so if you want to just kind of keep things consistent with me, then do that. If not, as long as you can keep track of where your data is, go ahead and type those into a list. So go ahead and stop the video now and get that done. Okay, got it? Then let's go through some of the questions here. First, it says, describe the association between ice cream sales and shark attacks. If you want to give it a shot first, stop the video, and I'll show you what I came up with. Okay, what did you come up with? Here's what I said. There's a strong, positive, linear relationship between ice cream sales and shark attacks. What that tells me is that as more ice cream is sold, sharks seem to attack more. Okay, and you can word that however you want, but that's basically what this data is telling us. With an increase in ice cream sales, there's an increase in shark attacks. Sounds ridiculous, all right, but that's, I don't know. What does that mean? That sharks know we eat ice cream and they like ice cream, so they're going to attack us more when we eat ice cream more? I don't know. But my guess is there would be some other reasons for why that might be. And that we can sort of tie into, again, why we cannot create a cause and effect relationship just by a regression analysis. Okay? Part B wants you to calculate the equation of the least squares regression line using your calculator. So I'll show, excuse me. So I'll show you how to do that real quick. Okay? So you have your data typed into your two lists. And so what we're going to do is we need to find our regression analysis function. It is a statistics calculation. So we want to go into stat over to calc. And there are two different least squares regression options here. You have option 4 and option 8. Option 4 gives you the equation in the form of ax plus b. We know it as a plus bx. Doesn't really matter which one you use as long as you can keep track of which one's the y-intercept and which one's the slope. I'm going to continue to use option 8 because it puts it in the form that statistics tends to want it to be in. So, and that's the form you're going to see it on the AP exam, so we might as well keep doing that. But if you hit enter, your 83ers, you may just be looking at Lin Reg with parentheses. I'm not sure. Maybe you have the same menu, but it's like anything else. What the calculator wants is where is your X list first? Mine's in list 1. That's my ice cream sales. And then it wants to know where your shark attack list is, your response. Mine's in list 2, so that's my Y list. And then your frequency list we're going to ignore. And then you do have the option of when the calculator calculates the equation for the least squares regression line that you can store it into one of your Y equals. To do that, we need to put a variable in there. So we go to vars, which is right here, and we go over to Y vars. That's where all of our Y's are. And if you hit enter on function, there are all, if you hit Y equals, you would see those same functions, Y1, Y2, Y3, Y4, Y5, whatever. I'm going to store my regression equation in Y1. When you do that, and you have the calculator calculate the regression equation, and it stores it in Y1 equals, then if you graph your scatter plot, it will draw the least squares regression line in your scatter plot as well. Okay? So I hit calculate, and boom. It populates everything. It reminds me of what form we're in, y equals a plus bx. It gives me my a, which is my y-intercept. It gives me my b, which is my slope. It does give me something called r squared, which we'll talk about in a couple of nights. And then it does also give me r. It goes ahead and it calculates r. So it went ahead and it created z-scores for all of my ice cream sales and all of my shark attacks, multiplied those z-scores together, added all those products up for each point, and then divided that by the n minus 1. And that's the 0.925 that you see right there. So that's your equation. So we need to go back and write that in. Okay? So the regression equation is this. And I would write it like this. It is, you could go attacks hat, if you want, or shark attacks hat equals negative 26.11. Now, rounding. How do you know where to round? Well, you need to use some common sense as far as your rounding goes. If you're talking about money, then round it to 2 decimal places. We're talking about shark attacks, so it would probably make enough sense to just round this to whole numbers because you can't have 0.11 shark attacks. But it's whatever you want to do. So we could just make this negative 26 plus, because our slope is positive, 0.08. I can't really round that to a whole number because it doesn't make any sense. Ice cream sales. Again, you could use y hat and x, but in order to put your context in, you'd have to come over to the side and say, okay, well, y hat stands for this and x stands for this. You'd have to still define them. So by putting the definition of the variables in the equation, you sort of take care of two issues with with doing that. Kill two birds with one stone, right? So anyway, that's your equation. So part C, interpret the slope in context. Again, if you want to give that a shot, I'll show you what I put down in just a second. Go ahead and stop the video, write out your interpretation, and then you can check yours with mine. Okay, what'd you come up with? We want to interpret the slope in context, and here's what I said. For every additional dollar in ice cream sales, the number of shark attacks increased by 0.08 attacks. Now, that's textbook interpretation of slope. And you can play around with this a little bit to make it make more sense. 0.08 attacks. You can't have 0.08 shark attacks. So what you could do is adjust this a little bit and say that for every additional $100 in ice cream sales, the number of shark attacks would increase by 8 attacks, right? We're going to multiply the x by 100, we can multiply the y by 100, and that might make more sense. But I would start here first and then adjust that interpretation as you see fit to make more sense. I'm going to leave it now as this. For every additional dollar in ice cream sales, the number of shark attacks increased by 0.08 attacks. Okay? Next question here for us is, does it make sense to interpret the y-intercept? Okay? And so what do you think? The y-intercept is negative 26 or negative 26.11. Does that make any sense? Take a shot at answering that question and make sure you talk about why. There's always an explain after that question, or at least usually. So again, stop the video, write that out if you want, and then you can compare your answer to mine. Okay, what'd you come up with? It doesn't make any sense to interpret the y-intercept because the y-intercept is negative 26. That means that if there's no ice cream sold, then there are negative 26 shark attacks. How do you have negative shark attacks? Right? Does that mean that we're attacking the sharks now? Right? That doesn't make any sense. So the y-intercept is there. It's a placeholder. It just doesn't make a lot of sense. Okay? And then the next question, calculate and interpret the residual for May. Well, we got to go calculate it. And then we need to interpret it. So let's take a shot at that. Right, so a residual, again, is defined as actual minus predicted. So in the month of May, the actual number of shark attacks was 47. And so what we have to do is go into our attack hat, negative 26 plus 0.08 times our ice cream sales for May, which is $1,100. Okay? We have to go figure out what the prediction would have been. Some quick calculation into your calculator suggests that we can do rounded here. I'm trying to think if it would make sense to try to do unrounded. But anyway, we can round it. It's no big deal. It's 62. And so the prediction said there should have been 62 shark attacks. So that gives us a difference of negative 15, right, if my math is right. Okay? So what does that mean? Great, wonderful, excellent. We got negative 15. Woohoo! What's that mean, right? Well, as an interpretation, that means that the regression equation I always have to kind of think about this for a second. And if the residual is negative, that means our prediction was larger than our actual. So that means that the regression equation over predicted the number of shark attacks by 15, or 15 attacks, right? Since we said shark attacks already, then we're okay there. Okay? And so that's how you want to interpret a residual. Next question, calculate and interpret R. We're not going to calculate R. The calculator already did that, right? R was 0.93. We're not going to go through and do the calculation for R ever again, okay? The calculator will do it. If you're not getting R and R squared when you do your regression analysis, make sure you come talk to me tomorrow, or maybe I can show you real quick tomorrow what you have to do. It involves going into your menu and turning your stat wizard on. If you want to give that a shot, then see if that works. But as far as interpreting R, simply saying that it supports the strong positive linear relationship between ice cream sales and shark attacks that we put in there before makes enough sense. Okay? But that's how you would interpret R as well. There's a strong positive linear relationship between ice cream sales and shark attacks. Now again, R alone doesn't tell us linear. So we'd have to have the scatter plot to verify that it actually is going to be linear. But because we have it, I know it's linear, I can go ahead and say it's strong, positive, and linear relationship. Okay? All right, we're going to keep going here. So I mentioned before that we can calculate the least squares regression line by hand, and we can. We have all the data in our table. What we need to calculate the regression equation by hand is the mean for our explanatory, the mean and standard deviation for our explanatory, and the mean and standard deviation for our response. So our x bar, s sub x, our y bar, s sub y, and we also have to have R. Okay? Now, without a lot of fanfare, or without a lot of here's where it comes from, here's how we go through and calculate this. So y hat equals a plus bx, we have to have a and we have to have b. Well, it's easier to find slope first because the slope simply comes from taking r and multiplying it by taking the standard deviation on y and dividing it by the standard deviation on x. Okay? It's just the way it is. I think we're all better off if we don't get too involved in the math behind it. That's just where the slope comes from. The y-intercept comes from taking your mean for your response, so y bar, and subtracting it by the slope times x bar. Okay? So this becomes a couple of formulas that we're just going to plug in. Okay? So for the ice cream and shark attacks, we have all of that information here. If we didn't, we had the 0.93 from our regression analysis. We could go in and do a one variable stat on our list 1 and list 2 and get these means and standard deviations. It's not that tough. So to calculate this by hand, I've got to find the slope. I've got to take 0.926, multiply it by 29.33 divided by 339.37. Okay? When we do that, quick division here gets us 0.08. Hey, look at that. That's what we got when we did our analysis in our calculator. The y-intercept comes from y bar, which is 49.42, minus this 0.08, which I'm rounding to write down, but I haven't changed in my calculator, so I can use the whole decimal, times x bar, which is 944.17. So I'll take the decimal in my calculator and multiply it by 944.17, and then I will take 49.42 and subtract that answer and get, hey, look at that, negative 26.14. Right, which supports what we said before. Attacks hat equals negative 26 plus 0.08. ice cream sales. Okay? So there you go. As you hear the bell went off and the music's playing, that must mean I have to stop now. So that's it for our notes anyway. The homework assignment is attached to the text. Again, we're going to have class for about 15 minutes tomorrow. So we'll do something else in class and then work on this homework on Thursday. So enjoy your night. See you guys tomorrow.